Welcome to this conversation with Professor Olivier de Weck. Olivier is the Apollo Program Professor of Astronautics and Engineering Systems at MIT and the Editor-in-Chief of the Journal of Spacecraft and Rockets. Previously, Olivier was the Editor-in-Chief of INCOSE Systems Engineering Journal. In today's conversation, we'll talk much about Olivier's work in technology road mapping, including his new book, Technology Road Mapping and Development, which contains many ideas that were deployed at Airbus, where Olivier was previously Senior Vice President for Technology Planning and Road Mapping for 2 years. Enjoy. Great. So thank you, Ollie. I was hoping we could talk about your new book, the Technology Road Mapping and Development, a quantitative approach to the management of technology. I guess for the listeners, just to start off, what is technology road mapping and why should their organization be doing it?
Yeah, good question. So a technology roadmap at its very simplest form is a map that has time on the x-axis, and on the y-axis you list your products, services, or missions that you're currently offering and that you plan to offer in the future as an organization. And then below that, you put the technologies that are necessary, enabling or supporting of those products, services, and missions, and you map the two against each other. And this helps you create a map, just like a map of the world, where you navigate, from here to there. And it helps you prioritize where should you put your investment, which technologies already exist, or you could just buy them off the shelf, and which ones do not exist off the shelf, and you have to create them or improve them yourself.
Okay, that's very helpful. And I guess if people think back to the 1960s when Kennedy said, we'll go to the moon by the end of the decade, is that clearly isn't a roadmap because we don't have any detail there of how are we going to get there or what technologies are needed to go there. However, would NASA at that time be, one, providing him a good basis to say by the end of the decade that he can't just make up this number or this arbitrary date, but two, it themselves be a sort of motivating factor to develop the technologies to get to that point?
Yeah, that's a really good example. In fact, the timing of your question is excellent because I was at the Harvard Kennedy School last night for dinner. We had a very nice dinner for celebrating the 1962 speech of John F. Kennedy, where he said, we will go to the moon and do the other things before this decade is out. Not because it is easy, but because it is hard. And we talked a lot about, there was a very famous memo that was sent by Kennedy to Vice President Johnson asking, what can we do to beat the Soviets? And there were many things on the table. Landing a robotic probe on the moon, but the Soviets had already crash landed a probe. Going to Mars. There were a lot of options there. And the challenge of landing a man at the time and bringing them back to Earth safely was chosen as, I want to say the middle ground, but it was chosen as a very ambitious goal where it was not viewed as utopian. And so behind Kennedy's speech, and a lot of people don't know this, but there was quite a bit of analysis done relatively quickly, but still over the course of several months at NASA. MIT, by the way, was very involved in that. Bob Siemens, for example, was very involved in those analyses, and Wiesner, who was Kennedy's science advisor, and they kind of did create a roadmap. At least they convinced themselves that the goal was not utopian, and that is, in a sense, the goal of road mapping is to set a target for the future, for missions, for technologies that's really ambitious. It's often driven by competition, but it's not so ambitious that you're almost certain to fail. So choosing the right level of ambition and timing is absolutely critical. And, you know, once you've set those targets, they can become self-fulfilling prophecies if you're really serious about them. You know, and we were serious about it during Apollo. It just cost a lot of money. You know, at the peak of the project, Apollo had 400,000 people working for it.
Wow.
It was 4%, 4% of the US budget was spent on Apollo.
Wow. Wow. So what the current US military spending is, what, 4 or 5% or something?
It's closer to, like, I think 3.7, 3.8, but
Okay.
it is about 4%. Yeah. So we
Yeah.
basically spent on Apollo, we spent about the same as what the US spends on defense year to year. So it's a lot.
Wow. Yeah, that's incredible. I think you mentioned the utopia point. There's lots of very nice diagrams in the book, but one I really like is where it's for the unmanned solar aircraft, and you compare various ones that exist in reality and also various projects that were attempted. I think there's one by Google, there's another by Boeing, and you have these two figures of merit. I think one is the amount of payload that the unmanned aircraft can carry, and the other is the duration of flight. And Boeing have set themselves this goal, which once you map it onto these figures of merit, I think, you know, you suggest, well, maybe this could be done in 2050 or 2060, but it is so far beyond what any of the enabling technologies could do. I just thought that one image sort of, to me, summed up this idea of you can have a roadmap, but it be going to a place that no one can achieve.
That's right. Yeah. You're talking about this one here, right? Figure 812.
Yeah.
Yeah, I love that. I love that figure too. And it took quite a bit of effort to make it. And I do recommend that whatever the technology is that you're interested in, whether it's, you know, nuclear fusion, whether it's medical devices, whether it's, you know, urban air mobility, agriculture. I think for many of the technologies that your listeners will be working on, the first step to making such an analysis and figure is to define your axes, right? The figures of merit. What really matters in your industry, your customers. And so clearly for solar-powered aircraft, endurance and payload are critical because it drives whether you can provide observation services or communications data relays and so forth. And that's where the Zephyr aircraft, which has been developed by Airbus, originally by Kinetic, actually from the UK, holds the current world record for electrically powered, solar powered aircraft. And the Boeing Solar Eagle that you mentioned, this canceled project, is a very interesting case study of setting goals that are way too ambitious. Boeing didn't do this on their own. They responded to a DARPA program. So, you know, DARPA is the Defense Research Projects Agency in the US, and they created a program called Vulture. So if your listeners want to Google this, you Google DARPA and vulture, like the bird vulture, you know, the vultures circle looking for their prey. And the vulture program said, we want an airplane that can fly without fuel, only solar powered, 5 years on orbit. That's about 1,800 days on orbit through the winter, right? And carry a payload of about 450 kilos, which is like the weight of like 5 people. It's a lot, right? And yeah, you can see this analysis that's in the book shows you that this is not a realistic target for when it was, you know, in 2005 or 2010, whenever the Vulture program was live, it was too ambitious. It was utopian. Eventually, I think we'll be able to get there, but, you know, based on the progression of that Pareto front, this looks to be more of a 2050 or 2060 target.
Yeah. Yeah, and that's one big takeaway I took from your book, was this quantification of via the figures of merit, and making these roadmaps grounded in some sort of technological reality, and I know you described sort of the limits and can we reach sort of the laws of physics as well, but showing, how many steps beyond are you from the current reality, and then the rate of progression of these technologies and feeding that all in. I guess my other big takeaway is around the multidisciplinary nature of a roadmap. And it isn't just a product of the engineering organization, that it must work with business and the other areas. I don't know if you could expand on that.
Well, that's true, very true, and I'm really glad that you really, I can tell you've really looked at the book and you're picking up the key messages very well. So kudos for that. Part of the book, or a large part of the book, is based on my experience at Airbus in Toulouse in 2017 and 2018. I was a senior vice president for technology planning there, working with and for the CTO, the Chief Technology Officer. And one thing I learned fairly quickly is you cannot make technology roadmaps in isolation, just researchers or engineers in the company. You need to work a lot with marketing, understand the future product plans, the customers. You need to work a lot with the Chief Financial Officer. And so I almost came to the conclusion that the CFO, the Chief Financial Officer, is perhaps the most powerful person in the company, maybe even more powerful than the CEO, because the CFO holds the purse strings, and the research, the development work that goes into the technologies is, for many companies, self-funded to a large extent. You can get external grants, government grants for low maturity technologies, but a lot of it is your own money. Some companies spend very little on R&D, 1%, 0.5%. Some companies, like in life sciences, spend a lot, 15%, 20% of revenues. So automotive, aerospace, electronics, many companies are sort of around 4 to 5%. So 5% of 60 billion euros in the case of Airbus, that's about 3 billion euros per year. And then you have to decide, okay, how do we allocate that? 3 billion a year is a lot of money. How do we allocate that to improve the existing products? These are product improvements. And then how much of it do we really put to future N+1, N+2 generation products? And roadmaps really help you rationalize that. And they help also explain to the CFO, and it's not just the CFO as a person, but the owners of the company, the investors in the company, the shareholders, explain to them, why is it important to invest in R&D? What's the expected return on investment? Not all projects will pan out, right? That's the nature of a portfolio, but you need a kind of priority list of key technologies. And traditionally, that priority list is created based on experience, intuition, whoever has the loudest voice in the boardroom. And what I've been trying to do with the book is change the dialogue, change it to become more grounded in reality of physics and economics and so forth.
Mm-hmm. And is that sort of traceability of, say, from business goals right down to research projects via, I think there's an MDM, multiple domain mapping, multiple domain matrix, through sort of 4 stages of, I think it was business goals, roadmaps, and then figures of merit, and then down to individual research projects. Is that traceability valued by, so as engineers, I think we often quite like traceability and seeing things connected together, but by others in the organization?
I would say it depends on the culture, obviously, of the organization and the company. In companies where technology is a very important part of the success of the company, and I think that is definitely true in aerospace and defense, it's definitely true in automotive, it's definitely true in medical devices, it's increasingly becoming true in fields that, like agriculture, for example. right? The energy industry, renewable energy. I think, I think there it is valued. It's a lot of work to put all this together and to show these links and traceability. You have to have workshops. You have to have dedicated roadmap owners. You have to validate each of these links. Is it really exist? Is it just one person saying that this is a key technology for that product? Do others agree? When you mathematically or physically model the performance of that product, does that technology, the parameter that that technology impacts, does it actually have a very high sensitivity? And then for those of your listeners that are mathematically inclined, constraints. Does the technology address an existing constraint or bottleneck in the system? And so I show also with the solar electric case that you mentioned that, for example, the PV, the solar cells themselves, they're already quite good in terms of their efficiency. Turns out they are not a bottleneck in the system. So we improve their performance. It doesn't really help you because that improvement for that component is quasi-invisible at the system level because you're not improving something that's an active constraint in the system.
Mm-hmm. Yeah, I think I remember that example, and that more effort should be spent on the batteries, which store that energy from the daytime into the nighttime, and you run them through the night. And if they don't have enough capacity or for given weight, which they have, then you can't continue your night flight.
Precisely.
There's another question with you start, well, clearly your career didn't start at Airbus, but in taking sort of road mapping to Airbus being, one of the world's most complicated companies and large companies, is it a good place to start at that end of the scale, or rather to some place more modest?
Wow, that's a good question. So the reason I was invited to come to Airbus from MIT, so I took a 2-year leave of absence. So I wasn't paid at MIT. It wasn't a traditional sabbatical. I really took a break. Was because, Airbus is, you're right, it's not a classic company. It's almost like a mini EU. Even though, the UK is an important partner country, home country, UK, Spain, Germany, France, the US now, Canada, China as well. And 3 billion a year investment in R&D. So it's very, very diffuse and complicated. And so the roadmaps were brought in to create some order and focus and rationality in that whole portfolio, which I think we've been able to achieve. One of the outcomes, quite publicly stated, is this focus on hydrogen now. You might have seen this. Like Airbus is investing significantly in, it's a program called Zero E, which means zero emissions, and it's at a core, it's replacing kerosene with hydrogen as a fuel. It's a fairly big bet. And other companies and competitors do not believe that that's the right direction, and they're being more, in a sense, traditional. So we'll see how it will play out. Now, can a small company or a startup benefit from road mapping? Absolutely. But instead of having 40 technology roadmaps like we had at Airbus, maybe you just have 1 or 2. Right, that are the core of your business. But those 1 or 2 roadmaps need to be very good.
Yes. And then with, say, an Airbus, you have a whole supply chain of suppliers. Some of those suppliers themselves are very large technology companies with Rolls-Royce or GE making engines. They themselves presumably would benefit from having roadmaps. But how to make that compatible with, say, the ultimate systems integrator, the Airbus or the Boeing?
Yeah, so let's take, the easiest example to explain is the engines, right? Like 1/3 of the cost of an aircraft, at least 1/3, is the engines themselves. And so this is Rolls-Royce, this is GE Aviation, this is Pratt & Whitney, primarily those 3. They do have internal technology roadmaps. And if you look at this is actually case number 2, case study 2 in the book is on the evolution of civil aviation. and we talk about the evolution of aircraft engines, you know, they're amazing. They're absolutely amazing machines. What do they do functionally? They provide thrust. They produce electricity, right, through the generators, and they produce air, you know, bleed air, which can be used in for cooling or heating different parts of the aircraft, air conditioning and so forth. More and more that's moving to electrification. But these large suppliers are very smart, they're very good technically, and they know that unless their technology roadmaps are synchronized somehow with their prime customers, they could waste a lot of money on products and technologies that will not be taken up. So there are mechanisms for exchanging between supplier and OEM, and it's quite sophisticated. And the simplest way to explain it is that you have a hierarchy of roadmaps. So, for example, an aircraft level roadmap would call that a level 2 roadmap. And the major air-breathing engines that we attach to those airplanes would be level 3 roadmaps. And then, for example, a new kind of compressor or the gear, you know, the fan drive gear system, which we see on the Neo engine, that's to me a level 4. It's more of a component level technology. But the output figures of merit of those lower level roadmaps become input figures of merit to the higher roadmaps. And so what you want to see is what we call chains of figures of merit that hold together across the full system decomposition, so that targets that you're setting for lower level component technologies, you can propagate them upward or downward. And this way, for example, an OEM can say, unless you can show an X% improvement on fuel burn, maintainability, operating cost, emissions, whatever it is, we're not interested in including that engine because it's not enough of an improvement for us to justify all the design changes we need to make at the aircraft level.
Yes, and I think earlier in the conversation we talked about the sensitivity of some of these sort of input figures of merit into that overall sort of rolled up measure that you're. I mean, I remember in the book there's, I think it's the Boeing 747, and you talk about, should we be improving the engine or reducing the overall aircraft weight, and some of those are more sensitive to the. In that case, it's trying to extend its the range so it can fly further with same number of passengers. And I guess at that point, you can then be pointing at particular suppliers to say, this would be highly beneficial to our overall system if this particular thing could improve itself by a certain percentage.
Exactly. So you're now moving from the kind of fuzzy qualitative discussion to very specific things you can measure and debate.
Yeah. Remaining at Airbus, one of the big challenges I find with very large corporations is just the amount of information can be so overwhelming that you can often, the thing you're actually after, you end up foraging for through just piles and piles of other things. And I know in the book you mentioned the need to keep the roadmap updated, and that it isn't a one-time thing, and that significant resources need to be provided for that. I mean, are you finding that sort of the companies you work for are willing to do that, or they're not willing to sort of keep that investment up?
That's a super great question as well. So yeah, you're right. There's a ton of information, more than a single human being can absorb. I mean, I guess in a small company, if you're, a small team, 1 or 2 people can take care of this, and they have everything in their head, and maybe you don't need a sophisticated system of roadmaps or database. But at Airbus, definitely it was needed. First thing we had to do was to create situational awareness. We ran some workshops, took about 6 months. A really wonderful place for us was the Airbus Leadership University in Toulouse, which they built just a couple years before. It's a wonderful facility, close to the airport, actually very close to the A380 assembly line. And we brought people together. We had hundreds of people join us for these workshops. And then by technology area, by product area, and we burned through thousands of Post-it notes. And it was super messy for a long time. However, after 3, 4, 5 workshops and sessions, the amount of new information, things that new projects, new R&D that you didn't know about, starts to decrease, and things converge. And then you clean it up, you map it, you create. We also created a standardized roadmap format that we imposed. Everybody had to follow that. And that really helped a lot create some order into the whole system. Now, and this doesn't come for free. You have to invest in it. So this is an interesting story in itself. Here's my pitch to companies that are hesitant to spend effort and money on road mapping. Imagine that you're investing not in technologies, but in your own retirement funding or investment portfolio, like a mutual fund. A mutual fund is what? It's a basket of investments, typically stocks and bonds. And if you want that mutual fund to perform well, and by well, I mean better than market average, you are typically willing to pay 1 to 2% per year as a fund fee, right? So you're paying the fund managers of your mutual fund to pick the right bets, pick the right stocks and bonds, so that year after year, the average performance of your mutual fund is above the market average. If you're happy with average performance, then you should buy an index fund, right? The index fund will track the New York Stock Exchange, the FTSE, the Nikkei index, whatever index fund you're interested in, and you don't need to pay a fund manager. It's just a direct replica of and your portfolio will be average. But most companies are not happy to be average. They want to be above average. And so my pitch is that, let's say you have $100 million or 100 million pound investment portfolio per year in technologies. You should be willing to spend 1%. So that would be about 1 million pounds or dollars per. I guess it's almost all at parity, right? The dollar.
Yeah, it is.
It's crazy. Like the pound, the dollar, the euro, the Swiss franc, they're almost all at parity with each other. It's unbelievable. Anyway, you should be willing to spend about 1 million per year for 100 million portfolio to make sure that the projects you pick, the allocations you make are the right ones and better than average. And that's what we did, and that's how we got to spend about 10 million euros a year on road mapping, which when you tell people that, they say, wow, that's incredible. That's crazy. 10 million a year just for road mapping. But remember, that 10 million will steer and influence a much larger portfolio to make sure it's above average and ideally industry leading.
Do you see any, maybe on the further horizon, sort of using AI or automation to help keep those roadmaps somewhat updated?
Yeah, so I don't think automatically updated. It's still sort of a human cognitive process. What we did is we designated typically 2 people to be roadmap owners of a roadmap. We had about 40 roadmaps, and we would pay either full or half salary for them. That's their main job. And I had this. I basically still say that. Being a technology roadmap owner should be one of the 10 coolest jobs in the company. And it really is a cool job because you get to really deep dive into the technology. You should go and visit universities, research labs, startups. You should attend conferences. You should read journal articles. You should look at the latest patent applications and really become an expert on that technology. And then inside the company, obviously, make sure that the right projects are being done, follow them. If there's any prototypes or demonstrators being developed, you want to be on top of that. So it's really, I think, a cool job. So automatic updating, probably not, but the technology scouting function, which at Airbus we had a separate technology scouting organization, and they're spread throughout the world, basically keeping their feelers out for new technologies, new ideas. So there I see the web crawling, AI, machine learning as being super helpful. Also in the area of IP analytics, there's like, I think over 1 million patents are now issued per year. It's a lot. Like if you look at the European, American, Chinese, Japanese, Korean patents, there's so much going on that AI and machine learning can really help you zoom in on the key information you need to update your roadmaps, and they should be updated at least once a year.
That's very good. This my other question is around disruptive innovation. I think in the book you talk about sort of incremental changes where we're improving the figure of merit by a small percentage, and maybe there's a wider industry trend that we continue each year. But then there are other times when a new figure of merit becomes the standard, and I think there's some examples of automotive where we have these large architectural changes from when steam cars were competitive to then internal combustion engine, and now maybe it's full electric. For the person who's creating, or the organization is creating their roadmap, how can they go about detecting these disruptive innovations? And you mentioned Airbus is experimenting with hydrogen-fueled aircraft, which I imagine would fit within this.
Yeah. I think hydrogen aircraft would definitely disrupt the existing industry. So absolutely, you're right that a disruptive innovation is one that looks inferior, at least initially, as viewed through the lens of the incumbents. And I need to give a lot of credit, and I think I do give a lot of credit in the book to Clayton Christensen at the Harvard Business School, who really has thought very deeply about disruption. And I follow him in many ways, his reasoning. And actually, he passed away, unfortunately, a couple of years ago. But the latest update of his book actually has a chapter on electric cars, which discusses this disruption. And if you think about what do people care about in electric cars, well, it's a lot of things like the range. Range was not really a big deal for gasoline cars, right? But now it is a big figure of merit. If you want to have a common figure of merit, you can't say miles per gallon anymore. You have to say something like megajoules per kilogram. So you have to bring it onto a common energetic basis. So the figure of merit itself and how you normalize changes, and it's challenging. It's challenging to either predict or create disruption, but that's where startups are really good. I think the startup ecosystem is all about working on initially niche kind of things where figures of merit that the incumbent firms don't really care about, but those new figures of merit become over time important and eventually maybe even dominant.
Thank you. Then my sort of other question on that sort of disruption is, in the outside environment, maybe not within your industry, we can have these large shocks. So a COVID-19 or a September 11th, which I mentioned those two because they had large impacts on aviation, and yet were not sort of caused by an aviation disruptor. I don't know if you were involved with the COVID-19 update, maybe to the Airbus roadmap, but how should an organization approach those types of things?
Disruption. So Airbus actually has a group internally that does kind of black swan type work, basically trying to predict these, pandemics or conflicts in regions where they have major customers, environmental disasters, and how would you react if this happens or that happens? So these quote unexpected disasters actually are often present in planning scenarios in the companies. Sometimes there's not much you can do ahead of time, but I think in terms of the volume of air transportation, the average, the key document there is the global market forecast, the GMF, which, over many decades had tracked about a 4.4% annual growth rate, compound annual growth rate. And all these disruptions, including SARS, the financial crisis of 2008, 2009, you can see them. They are disruptions. They look like a blip. And I think COVID-19 is a huge blip, right? But somehow it seems like the deeper underlying demographic and economic drivers of society, which is, more affluence in Asia, a rising middle class, an aging population in Western countries, increased environmental concerns. Those are big mega trends that occur in society over, let's say, over decades. Those end up still dominating the long-term response of the system, despite these important but shorter-term disruptions. And so I have not actually seen the latest post-COVID global market forecast, either from Airbus or from Boeing. But my guess is that it does predict further growth of the industry, but with a delay, right, due to the post-COVID recovery, and perhaps a more modest growth rate.
Yeah, certainly. I think like this summer, the constraint was on essentially more people wanted to buy tickets than there were tickets available because of staffing issues. So it felt like air travel had recovered. Great. So what I'll do is for the below, I'll put links to get the book. But I know that you have a course which people can sign up to with MIT.
That's right. So we are offering through MIT Professional Education. It's actually 2 courses. It's a part 1 and a part 2. You can find it on the MIT Professional Education website. It's been fairly popular. We started this course about 18 months ago, and I've been really happy to see the uptake. It's a purely online course. It's about 8 weeks. Part 1 covers chapters 1 through 10 in the book. So it does cover technology road mapping, the history of technology, how to construct figures of merit, and so forth. And the first 2 cases, which is the automobile and civil aviation. And then part 2 is chapters 11 through 22, which covers more the strategic and portfolio level. So now you're dealing with multiple technologies and you're trying to rank them. So if any of your listeners are interested to look at those courses, please go to the MIT Professional Education website, and we'd love to have you.
Great. So I'll put the links down below. Anything further to add, Ollie?
No, I would just say thank you for the invitation. Wonderful podcast. I was really impressed by your questions, and I'm happy to just continue working on this fascinating topic, because the role of technology in the future of our society and our planet is a crucial one.
Yeah. Thank you, Ollie. Thank you.
Thank you so much. Take care.